begin our discussion about undercarriage design and function, let's first briefly review a few basic facts about track-type vehicles in general. As opposed to rubber-tired equipment, which offers speed as its prime advantage, track-type vehicles offer increased traction capabilities in varieties of terrain. The undercarriage of a track-type vehicle accounts for approximately 20% of the initial machine price, but accounts for an estimated 50% of the total maintenance cost in the life of these units. The undercarriage thus becomes a very important machine component when examined from a functional, maintenance, or cost viewpoint. And just what is the function of the crawler undercarriage? Very simply, the undercarriage supports the machine, gives the machine mobility, and provides flotation. With the functions of the undercarriage now in mind, we must now look at undercarriage design to determine how these functions are accomplished. To generalize for a moment, we can say that the undercarriage design for both crawler dozers and crawler loaders is essentially the same, the only real difference being the manner in which the undercarriage is mounted to these units. Let's first observe the basic undercarriage components and their relation to each other. A detailed discussion of individual components will follow. The track frame is the foundation of the undercarriage in that it provides a housing or mounting for other components. Housed within the track frame is the recoil mechanism, which serves as a shock-absorbing device for loads imposed at the front of the undercarriage. Integral with the recoil mechanism is the hydraulic track adjusting device. The track frame also houses the front idler fork, which is the supporting member for the front idler. The front idler is a large wheel-like steel casting that supports the front of the track. Grooves on the circumference guide the track chain. The sprocket is attached to the tractor's final drive unit and provides the power to drive the machine. Bolted to the bottom of the track frame are a number of track rollers, which support the tractor and provide a running surface for the track chain. The track chain is a flexible chain composed of two rows of individual links pinned together. The links serve as mounting pads for the track shoes, and the pins, which are encased in bushings, serve as leverage points for the sprocket to drive the track. The upper portion of the track is supported by the top idlers, which are mounted to the track frame. As was mentioned before, the track frame is the foundation of the undercarriage, providing a mounting or housing for other undercarriage components. International uses two basic types of track frames: fabricated box and fuselage. The fabricated box design, with minor variations for the various models, consists basically of two heavy steel channels bridged with a thick top plate. Heavy contoured plates are welded to the top plate to provide a recoil mechanism housing and a cover and guide rails for the front idler fork. Retainer plates are used at the front of the track frame on either side to keep the idler fork in position. After installation of the fork, the retainer plates are swung up into position and secured with the top bolts. The chain guides, which are blocks of steel welded on either side of the frame, guide the chain between the front idler and rollers. The fabricated box frame is used on all international crawlers and loaders except the 25B and 25C. The TD25B and C use the fuselage-type track frame. This track frame consists of a single steel plate formed in an inverted U shape. Internal bracing is used to give the frame added strength. This fuselage track frame is one of the strongest in the industry. Most competitive crawlers in the 25B or C class cannot compare in track frame strength with the international fuselage design. Housed within the track frame is the front idler recoil mechanism, which serves as a shock-absorbing device for loads imposed at the front of the undercarriage. With the exception of the 25B and C, all international crawler dozers and loaders use a large coil spring for the recoil function. Notice also that between the spring and front idler is the hydraulic track adjuster that keeps proper tension on the track chain. More about this in a moment. The recoil mechanism on the TD25B and C consists of a series of conical spring washers enclosed in a housing. This type of recoil mechanism is an international exclusive and is simpler in design and requires less maintenance than the recoil mechanism on other crawlers the size of the 25 series. This conical spring mechanism requires no lubrication or gas charging, as do most competitive designs. Integral with the recoil mechanism is the hydraulic track adjuster, a simple hydraulic cylinder which can be adjusted by adding or relieving lubricant to give proper tension on the track chain. A piston fits into the bore of the cylinder, and as lubricant is forced into the cylinder, the piston pushes against the shaft of the idler fork and moves the front idler forward. The trapped lubricant then maintains proper tension. If tension is too great, that is, if the track chain is too tight, lubricant can be relieved from the cylinder. The fittings for controlling the amount of lubricant are accessible through a cutout in the track frame. In other units, the shaft of the idler fork serves as the cylinder for the adjusting mechanism. A piston is installed in the shaft, and an adjusting rod is positioned between the piston and recoil spring. The two fittings on the top of the fork are readily accessible for adjusting track tension. The front idler serves as the front support and alignment point for the track. The front idler on all international crawlers is one position, meaning that the front idler is positioned in the track frame to allow maximum tractive effort and efficiency when dozing or doing drawbar work such as ripping. Some competitive machines use a two-position front idler, one position for dozing, the other for drawbar work. This type of idler must be manually reset. In construction, the front idlers on international machines are hollow, drum-type steel castings with induction-hardened wear surfaces. The idler is mounted on permanently lubricated tapered roller bearings and incorporates metal-to-metal seals to prevent dirt entry. The sprocket, of course, provides the motive power to the track, using the bushings in the chain as leverage points. All international sprockets are fully machined to exact tolerances and incorporate the hunting tooth design. This means that each sprocket tooth makes contact with a chain bushing only once in 2 revolutions of the sprocket. For example, if 4 consecutive sprocket teeth were numbered 1 through 4, teeth 1 and 3 would make contact on the first revolution of the sprocket, 2 and 4 would ride free. On the second revolution, 2 and 4 would make contact, and 1 and 3 would ride free. The hunting tooth feature is accomplished by chain design and by using an uneven number of teeth on the sprocket. Hunting tooth design increases sprocket life. International uses 4 basic types of sprockets. A 3-piece segmented sprocket is used on the TD25C. The segmented design allows sprocket removal without removing the track frame. If pinion shaft removal is required, the smallest of the 3 segments can be indexed with the pinion shaft cover. When the segment is removed, the shaft is easily accessible. A spoke-type sprocket is used on the TD25B, TD9B, and the 150 loader. The 25B sprocket also incorporates a 3-tooth segment, indicated in white, which, as on the 25C, allows easy removal of the pinion shaft. The sprockets on these machines are splined to the final drive carrier. The sprockets on all other units are bolted to the carrier. The one-piece ring-type sprocket is used on the medium-sized dozers and loaders. Because the track frames on these machines are mounted forward of the sprocket can be removed without disturbing the track frame. The small dozers, TD7C and 8C, as well as their loader counterparts, the 100C and 125C, use a solid one-piece sprocket. And again, as on the medium-sized machines, the sprocket is easily removed because the track frame is mounted forward of the sprocket. The teeth at the bottom left of the sprocket are covered by the rock deflector. The track rollers support the machine and provide a running surface for the chain. The track rollers are mounted to the underside of the track frame. Notice that both single and double flanged rollers are used to keep the track chain in perfect alignment. The single flange rollers ride on the outside of the chain, while the double flanged ride on both the outside and inside to keep the chain in alignment. Track rollers consist of a forged steel shell, which has bronze or aluminum bushings pressed into the inside diameter. These bushings center the shell on the hardened steel shaft. A thin film of oil separates the two components to ensure long life. The ends of the shaft are placed through brackets mounted to the track frame. Metal-to-metal seals and rectangular pressure rings keep lubrication in and dirt out. Notice that there are large lubricant reservoirs in both the shaft and roller shell to both cool and lubricate the assembly during the operation. The track chain, of course, gives the tractor mobility. The track chain consists of 2 rows of individual links joined with pins and bushings. The links are made of drop-forged, heat-treated steel and have a large bore at one end and a smaller counterbore hole at the other. The bushing is pressed through the large bore and rides within the counterbore of the mating link. 2 concave metal spring washers protect the bushing and link surfaces from galling and keep out harmful abrasives. The pin is placed inside the bushing and is pressed into the small bore. The links are tapped for mounting the track shoes, and each link has a broached notch to receive a small key on each shoe. This feature of keying the shoe to the link relieves stress on the shoe mounting bolts and is an international exclusive. The link pin bushing arrangement is seen more clearly with this cross-section top view. Notice the position of the metal sealing washers. The top idlers support the upper portion of the track between the front idler and sprocket. The idlers are heat-treated steel forgings and are supported by a bracket which is welded to the track frame. The idler shaft is bolted to the bracket, and the idler then installed on the shaft with bearings. We've discussed so far the basic components common to all undercarriages. Now, let's look at how the undercarriage is mounted to the tractor. Here's where the dozer and loader undercarriages differ. On a dozer, the undercarriage is mounted to allow the track frames to oscillate vertically, independent of each other. This feature allows the dozer to operate in rough terrain and yet maintain sure-footed balance. But for a loader, a stable working platform is all important. To provide this stability, the undercarriage is rigidly mounted. The track frames cannot oscillate. The 2 small dozers in the international line, the TD7C and TD8C, are exceptions in that their undercarriages are rigidly mounted in the same manner as their respective loader counterparts, the 100C and 125C. A rigid undercarriage is used on these small dozers because they will probably never be used in really rough terrain. Looking in detail at undercarriage mounting on the crawler dozers, the TD9B, TD15C, TD20C, TD25B, and TD25C, we find many similarities. All are equipped with an equalizer bar, a pivot shaft, and track frame guides. The equalizer bar is the front oscillating support, which secures the front frame of the tractor to the undercarriage. A pivot pin mounted in a bushing at the center of the bar secures the equalizer bar to a bracket on the bottom of the front frame. The ends of the equalizer ride on hardened steel pads inserted into the track frames, as on the 25B and C at the left, or placed on top of the frames, as in the other units. A rebound bracket is placed over each end of the bar to ensure that the track frames and equalizer bar move as a unit. In addition to supporting the front end of the tractor, the equalizer bar provides free track oscillation, or in other words, allows each track frame to move vertically independent of the other. The equalizer bar then keeps the tractor relatively level when working in rough terrain. We should note here that the equalizer bar on the TD25B and C is resilient, meaning that the bar will flex nearly an inch to provide a better ride for the operator. The equalizer bars on the 9B, 15C, and 20C do not flex. The pivot shaft, mounted either through the center of the sprocket or directly in front of the main case, provides the rear tractor to undercarriage mount. The pivot shaft provides the pivotal point for track frame oscillation. The TD9B, TD25B, and TD25C have a pivot shaft pressed into the main case and extending through the center of the sprocket. Notice that the 25B and C, as shown here, actually have two pivot shafts, one for each track frame. The 9B has a one-piece shaft. This is a simplified view of the track frame to pivot shaft mounting on the TD25B and C. The track frame is first placed over the end of the shaft. The 25C incorporates a socket pressed into the frame, which forms half of the race for the pivot bearing. The track frame on the 25B is fabricated to form this half of the race. With the frame in place, the pivot bearing is then installed over the end of the shaft and bolted to the shaft. The bearing cap, which forms the other half of the bearing race, is then bolted to the track frame. The TD9B uses the same general type of bearing mounting as do the 25s. However, the track frame is not installed over the pivot shaft. Instead, a bracket is bolted to the top of the frame and the pivot shaft extends through the bracket. The pivot shaft on the TD15C and TD20C is clamped and doweled to the front face of the main case and to the front of the final drive housings. On these machines, the track frame is placed over the end of the pivot shaft and oscillates on the two bushings. A thrust plate, larger in diameter than the end of the pivot shaft, is bolted to the end of the shaft to secure the track frame. Wear plates are used to prevent galling of the frame and end cover when the track frame pivots. Shims are used to provide precision location of the frame on the shaft. The track frame guides mounted behind the equalizer bar on each track frame keep the frames in vertical alignment as they oscillate. There are two basic types of track frame guides. The 15C and 20C use a large guide plate that is bolted to cast pads on the tractor's front frame. A vertical rail and two wear strips are placed over the plate. The assembly shown here will be bolted, top and bottom, to a second rail that is welded to the track frame. The 25B and C and the 9B use a roller instead of the guide plate. The roller is clamped between two vertical guide rails, one welded to the track frame and the other then bolted to the first at the top and bottom. This specific guide is used on the 25 series machines, but the TD9B uses the same basic roller type guide. The 9B and the 25B and C have an additional undercarriage mounting, two diagonal braces. The diagonal braces are L-shaped box frame members. One end of the brace is welded, as on the 25B and C, or bolted, as on the 9B, to the rear of the track frame. A large mounting pad is machined into the other end of the brace. The pad ends of the diagonal braces are mounted with bushings and clamps to the center of the pivot shaft on the 9B and to the inboard ends of the two pivot shafts on the 25B and C, as shown here. The main cases on these units are fabricated to expose the pivot shafts and to provide clearance for the clamps used to secure the braces to the shaft. These braces provide additional stability for the undercarriage and also serve as an additional pivot point for the track frame oscillation. Let's briefly review our discussion about dozer undercarriage mounting. The undercarriage on the TD9B, TD15C, TD20C, and the 25B and C are designed to oscillate. All are equipped with an equalizer bar, pivot shaft, and track frame guides. The 9B and the 25B and C also incorporate diagonal braces. How about loader undercarriage mounting? Loader undercarriage mounting differs from the dozer mounting in that the loader mounting is rigid and allows no track frame oscillation. The 250C, 175C, and 150 mounting is quite similar. Each uses two mounting bars which have large fabricated pads on each end for securing the bar to the track frames. Each bar is rigidly mounted to the underside of the main frame. This type of mounting provides a stable platform for the loader, which usually operates in fairly level terrain. The 250 and 175 also incorporate a coupling link at the rear of each track frame. This link is pinned to the final drive housing and to a bracket which is bolted to the track frame. These links keep the track frame and final drive housing in alignment and transmit frame shock loads to the ground. We should mention here that although the 150 loader's undercarriage is rigidly mounted with two bars, the rear of the track frames are bracket mounted to a shaft in exactly the same manner as its dozer counterpart, the TD9B. The 125C and 100C loaders, as well as the small dozers, TD7C and TD8C, have rigidly mounted undercarriages, but unlike large loaders, use only one rigid bar. This bar is positioned under the front of the main frame. The rear mounting for the undercarriage consists of a shaft mounted to the front frame on both sides. The rear of the track frames are secured to these shafts by round brackets welded to the top of the track frame. A retaining link fits into a notch in the ends of the shaft and is bolted to the outer bracket to keep the frames in place. After discussing standard undercarriage components and mounting, it would be beneficial at this point to look briefly at optional undercarriage components that allow a tractor to be suitably equipped for specific applications. For instance, there is a variety of track shoes for tailoring crawlers to work in certain soils and terrain. Track shoe design and selection is vitally important because the shoes provide the footing to support and distribute the weight of the tractor. They must do so regardless of soil density and composition or terrain. In order to meet these requirements, track shoes are available in a wide range of sizes and widths, with varying profiles and metallurgy. There are various aspects of dozer track shoes relating to specific applications. For example, a machine can be equipped with severe service shoes in lieu of the standard shoes. The severe service shoe has a thicker grouser than the standard shoe. Standard shoes are used for general contracting, topsoil movement, and for agricultural work. Severe service shoes are normally used where rock is prevalent, such as in mines or quarries. Shoe width also should be tailored to the application. Wide shoes provide flotation and are used in soft soil, such as sand or marshy areas. Generally speaking, the proper shoe width is dependent on tractor weight and soil conditions. But remember that the narrowest shoe that provides flotation is the shoe that should be used. The narrower the shoe, the greater is the pressure per square inch on the grouser. This pressure results in good penetration and good traction. Using shoes that are too wide can result in the grouser not penetrating and in increased wear on undercarriage components. The grouser permits the shoe to grip the ground and, under favorable conditions, will penetrate to its full depth to allow the tractor to be supported by the flat area of the shoe. Grouser height thus becomes important. High-profile grousers are usually used on crawler dozers to give a large grouser area for footing. Shoes with a low-profile grouser are usually used in applications where traction is not the prime consideration, such as in gravel or loose rock. Grouser configuration must also be considered. The grouser can have a square corner or clipped corner. The clipped corner grouser is preferable in almost all applications except steep grade work or continuous side hill work, where the square corner serves as a deterrent to side slip. In normal operations, the square corner would be a hindrance to turning and would increase drivetrain and undercarriage loads. If a tractor is worked consistently in soft snow or mud, shoes with a center cutout are advantageous to allow the material trapped between the chain link assemblies to escape. A low-profile triple grouser shoe is normally used on loaders where a stable working platform is more important than traction. In fact, this type of shoe allows track slippage to protect the loader from damage. As with dozers, loaders can usually be fitted with wider shoes if the application dictates their use. The selection of a track shoe to meet all conditions of climate, soil, terrain, and application is an impossible job. Impossible, that is, if perfection is the objective. Any selection of track shoes is more or less a compromise to fit the tractor with a good all-around shoe for the job at hand. Another option for equipping the tractor for special service is the severe service undercarriage available for many models. The severe service package consists generally of heavy-duty rollers, heavier and wider track links, heavier pins and bushings, severe-duty shoes, a heavy-duty sprocket, and guards for the rollers and sprockets. If the tractor will be worked in rough, rocky terrain or in highly abrasive soil, thought should be given to equipping the unit with a severe service undercarriage. No matter what the application, roller guards and rock deflectors are always good insurance. Equipping the undercarriage with proper options will help extend undercarriage life. However, no matter what precautions are taken, the undercarriage does wear. Friction between the chain and front idler, top idlers, rollers, and sprocket will cause these components to wear, and the more abrasive the soil, the greater the wear. Here are some of the factors affecting undercarriage wear. A complete discussion of undercarriage wear could well be a program in itself. Here we will limit our discussion to the most common source of undercarriage wear, the wear between the pins and bushings in the track chain. When the tractor is moving, the pins are turning inside the bushings as the chain travels around the sprocket. An interesting point here is that internal pin and bushing wear occurs on only one side of these components. The gap created between the pin and the left-hand side of the bushing wall is the result of the pin and bushing wearing on the right side. This one-sided wear on pins and bushings allows the pins and bushings to be turned or rotated 180 degrees in the chain to bring unworn surfaces to the working area. Turning the pins and bushings is required when the wear in these components allows the track to stretch beyond specified tolerances. The effect of turning pins and bushings is shown here. In the top chain, the pins and bushings are new, and the pitch or distance between the centers of two pins is a specified length. As the tractor is worked, wear occurs between the pin and bushing, and the track becomes longer or stretches. The gaps on the left side of the pins in the second chain are the result of the pin and bushing wearing on the right side. As this wear occurs, the pin moves away from the left wall of the bushing. In the bottom chain, the pins and bushings have been turned. Because new surfaces are now at the working area, the pitch is restored to its original length and the track shortens. The gap between the pin and bushings on the left side is now the result of the wear in both parts. This completes our program on undercarriage basics. But of course, there is more to be learned. For you servicemen, there are technical manuals that discuss in detail how to evaluate the condition of the undercarriage and how to rebuild or repair the undercarriage when required. You salesmen will be interested in specific undercarriage facts for the machine you're selling. The basics we've discussed here should give meaning to those facts in the spec sheet and enable you to confidently discuss undercarriage sales features with your customer. Serviceman or salesman, product knowledge is an asset.